Okay, welcome back students, and myself Chandra Prakash and Faculty of Chemistry, Ecet, and this is Ask Engineering Academy, Dilsukhnagar, and this institution mainly focuses on the many entrance examinations, especially Ecet, Mset, NEET, and various IIT, and the students, those who are watching this YouTube, you can, if you really want to interested to join this academy, you can contact the details which are given below in the description box. And after the completion of, in the last topic, in the last class, we have studied about two important things. One is metallurgy and corrosion, and after that, one more important thing, basically about 30 to 40% of questions generally asked from this electrochemistry in many kind of competitive examinations, that is electrochemistry. So what is electrochemistry, what are the terms involved in it, and how the electrochemistry branch mechanism will be employed. And in this electrochemistry, coming to the contents of electrochemistry, first, conductors. What are conductors? How the conductors are generally formed? What are the properties of conductors can be studied in this. Second one is insulators. What are insulators? Next, electrolytes. This is very important. Types of electrolytes. What are the electrolytes and how the electrolytes are divided. Now, finally, Arrhenius theory of electrolytic dissociation. What is meant by Arrhenius theory? How Arrhenius theory has proposed a theory to explain the mechanisms that involved in electrochemistry. And electrolysis. Electrolysis of fused NaCl, it is a kind of mechanism which is a type of electrolysis actually, and aqueous NaCl. Fused NaCl and aqueous NaCl, those are two important things. I will explain what is meant by, what is the differentiation between fused NaCl and aqueous NaCl in upcoming class. And applications of electrolysis, Faraday's laws of electrolysis, and numerical problems. Numerical problem. This is all about today's class, that is the topics and contents of today's class, that is electrochemistry. Now moving on to conductors, insulators. Before that, now I will give an idea what is meant by introduction. Introduction to electrochemistry. Actually, what is meant by electrochemistry? Electrochemistry is nothing but, it is a branch of chemistry, especially it is a branch of physical chemistry. It is a branch of physical chemistry. It mainly deals with how the electrical energy is associated with chemical energy. So electrochemistry is nothing but, it's a branch of science, especially branch of physical chemistry, in which we usually study how the chemical energy and electrical energy are exchanged mutually. So electrochemistry. 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 So it is a branch of physical chemistry actually. So branch of physical chemistry. Branch of physical chemistry. Physical chemistry. It especially deals with study of interaction between chemical energy and electrical energy. Chemical energy and electrical energy. Chemical energy and electric energy. So electrochemistry is nothing but, it is a process, how electrochemistry is a branch of science which deals with how the chemical energy is interacted with electrical energy. Chemical energy interaction with electrical energy, we usually study this in electrochemistry. And generally electrochemistry also deals with deals with chemical changes, also deals with chemical changes within the molecule, within the molecule due to current or electric current or electricity simply. So electrochemistry is a branch of science. It deals with interaction of electrical energy with kinetic energy, electrical energy with chemical energy. Not only that, it also explains what are the chemical changes that usually happens within the molecule when electric current is passed through it. So this is also called as electrochemistry. This is the basic definition of electrochemistry. So this is all about electrochemistry. Now we are moving on to what are conductors, what are insulators, what is electrolyte. Before going to this classification, I will make you understand what is meant by the term electric current. Now electric current means what? Electric current is nothing but it is a phenomenon which generally happens due to flow of free electrons, due to movement of electrons, generally electric current is represented or expressed in terms of movement of electrons, which is generally expressed as movement of electrons. These electrons are generally generated by batteries. Batteries when the circuit is completed or closed circuit simply. When circuit is completed. So electric current is nothing but it's a process of movement of electrons which are generally generated by the batteries by closing of circuit or by completion of circuit is called as electric current. Generally the unit for electric current is amperes. So in this universe substances are classified according to the ability to carry electric current. Based on the ability of the material or based on the ability of the substance to carry the electric current, the substances are classified into three types. Those are conductors, depending upon property of electric current. This classification is purely based on how much the substance can allow the current to pass through in it. దాని నుండి ఎంత పోతుంది కరెంట్ పాస్ అవుతుంది, దాన్ని బట్టి ఎలక్ట్రిక్ సబ్స్టెన్సెస్ అనేవి త్రీ టైప్స్గా క్లాసిఫై అయ్యాయి. వన్ ఈజ్ కండక్టర్స్, సెకండ్ క్లాసిఫికేషన్ ఈజ్ ఇన్సులేటర్స్, థర్డ్ వన్ ఈజ్ ఎలక్ట్రోలైట్స్. So these are the three substances can be classified based on the ability to carry electric current. Now first classification is conductors. What is conductors? What are conductors? Conductors are the substances that allows the electric current to pass through it. That means conductors and ఏంటంటే వాటి నుండి electric current ఈజీగా పాస్ అవుతుంది. So electric conductors or conductors are simply the materials or the substances that does not offer any resistance to the flow of electrons or flow of current. That means current can easily flow through the some material. Those materials are called as conductors because it allows the electrons or electric current, simply electric current to pass through. These are called as conductors. The best examples for the conductors are all metals. Examples are metals, all metals, and graphite, which is a non-metal graphite, and aqueous solutions of acids, bases, aqueous solution, I am repeating again, acid, bases and salts. So these are the best example for the conductors that conducts electricity because they have free electrons. There is a possibility of movement of electrons. Because of that reason, they are considered as conductors. Now, insulators. It is the reverse of conductors. Conductors are easily passes the electric current. Insulator means they offer resistance, they will act as barrier for the flow of electrons. So, the substances that do not allow current to pass through in them, those are called as insulator. It does not allow current, doesn't allow the current. Those are called as insulators. The best examples for the insulators are non-metals, plastics, non-metals, plastic. These are the examples for insulators. And now third one is electrolytes. So this is a special category. Now electrolytes is also studied under conductors, because electrolytes are also good conductors of heat and electricity. Now conductors are again classified into two types. In one is metallic conductors, another one is electrolytes. Now moving on to see. Now I am explaining conductors. Conductors are again classified into two types. In that, one is metallic conductors, two is electrolytes. Metallic conductors. Metallic conductors. Second one is metallic conductors, electrolytes. See, electrolytes. So conductors are the substances that allows the current to pass through. Again, the conductors are categorized into two types. One is metallic conductors, one is electrolytes. So now we are moving on to metallic conductor. What are metallic conductors? So metallic conductors are nothing but, these are the conductors that allows the electric current, but there is no decomposition or degradation of metal. So conducts electric current or electricity, but there is no decomposition of metal. Decomposition of metal. It conducts electricity, but there is no chance of decomposition of metallic surfaces. The metals cannot be decomposed. That's why these are called as metallic conductors. Generally, the best example for metallic conductors are all metals. What are electrolytes? Electrolytes are special kind of conductors, but it also good conductors of electricity. It also allows electric current, but there is a chance of decomposition of electrodes. Electrolytes simply is defined as simply electrolytes are nothing but conductors in which the metals are decomposed. See, conductors in which the metals are decomposed in electrolytic solution or any aqueous solution, in any aqueous medium, simply aqueous medium. That means whenever any metal is taken into the aqueous medium, that is our moisture containing solutions, when the metal is exposed to electrolytic solutions such as salt water or water, simply when electric current is passed through it, due to that flow of electric current, the metals what we are using can be decomposed. So decomposition of metals are generally takes place, and these electrolytes can be gives rise to ions. Electrolytes are decomposed to ions when the electric current is passed through it. When we supply electric current, for example, this is electrolyte. When electric current is passed through this electrolyte degraded or decomposed into ions. Due to the movement of this ion, passing of current will be possible. So this is what electrolytes. Electrolytes are nothing but, these are also class of conductors, but they undergo decomposition upon electricity is applied. This is called as electrolytes. So now you get an idea what are the substances, three based on the electric current capability. One is conductors, insulators, electrolytes. Electrolytes are widely studied under the category of conductors. Apart from the electrolyte, another conductor category is metallic conductors. This is all about different types of substances. Now types of electrolytes. Generally there are two types of electrolytes are existed. One is strong electrolytes and weak electrolytes. Strong and weak electrolytes. These electrolytes are classified into strong and weak electrolytes based on the degree of dissociation. Based on degree of dissociation of ions. Dissociation of ions. For example, strong electrolytes means what? Strong electrolytes are nothing but these are electrolytes which can be completely dissociated into respective ions. That means when this electrolyte is placed in an electrolytic solution, by application of electric current, these electrolytes completely dissociates into ions. అంటే ఈ ఎలక్ట్రోలైట్ని ఎప్పుడైతే మనం ఎలక్ట్రోలైటిక్ సొల్యూషన్స్లో పెట్టినప్పుడు ఎలక్ట్రిక్ కరెంట్ అప్లై చేసినప్పుడు ఆ ఎలక్ట్రోలైట్ అనేది కంప్లీట్గా అయోనైజేషన్ అయిపోతుంది. దాన్ని ఏమంటారు? అయోనైజేషన్ ఆర్ డిసోసియేషన్ అంటారు. సో దోస్ కైండ్ ఆఫ్ థింగ్స్ ఆర్ స్టడీడ్ అండర్ స్ట్రాంగ్ ఎలక్ట్రోలైట్. ద బెస్ట్ ఎగ్జాంపుల్స్ ఆర్ స్ట్రాంగ్ యాసిడ్స్. బెస్ట్ ఎగ్జాంపుల్స్ ఆర్ స్ట్రాంగ్ యాసిడ్స్ and strong bases are the best examples for strong electrolytes. For example, strong acid. HCl is an example for strong acid and NaOH is an example for strong base. HCl completely dissociates into H plus and Cl minus. NaOH will be completely dissociated as Na plus and OH minus. So these are the ions. So the degree of dissociation is 100% here. Here also 100%. 100%, the rate of dissociation is 100%. That means HCl is acid which is dissociating completely into H plus and Cl minus ions respectively. So because of complete dissociation, it is studied under strong electrolytes. Now weak electrolytes, best examples are, there is no complete dissociation. There is a chance of formation of another products or intermediate products. Weak electrolytes, best examples are weak acid and weak base. Weak acid and weak base. The best example for weak acid is acetic acid, ACOH, acetic acid, and weak base is weak base sodium hydroxide, potassium simply, ammonium hydroxide. It is an example for weak base. In these kind of bases and acids, the dissociation of ions is not that much complete. There is a partial dissociation, not incomplete dissociation. So if there is incomplete dissociation of ions in the electrolytic solution, then those are called as weak electrolytes. These are called as strong electrolytes. So these are the types of electrolytes. Now Arrhenius theory of electrolytic dissociation. Now first, Arrhenius is a scientist who proposed a theory in order to explain how the electrolytes are dissociate. Electrolytes ఎలా dissociate అవుతుంది అని చెప్పడం కోసం Arrhenius అనే సైంటిస్ట్ ఒక థియరీని ప్రపోజ్ చేశారు. That theory is called as Arrhenius theory of electrolytic dissociation. So according to this theory, there are some postulates or some points. First point is, according to this theory, there are some postulates. First postulate is postulate 1. Postulate 1, according to this theory, the first postulate is all electrolytes will electrolytes in solutions, all the electrolytes in the solutions spontaneously undergoes dissociation. of ions, dissociation. See, all electrolytes in solutions, when electrolytes are taken, that means 90% of electrolytes, when they are taken into aqueous solutions or electrolytic solution, they undergo dissociation into respective ions. Then the formed ions are two types. One is cations, second point, cations and anions. Cations are nothing but positively charged species, anions are nothing but negatively charged species. Okay. Next, third point is the cation or anion, after dissociation, they always try to unite again to form undissociated complex. That's, for example, this is NaOH. During electrolysis, it forms as Na plus or OH minus. But during the process of electrolysis, according to Arrhenius theory, these two ions always wants to be unite to form again NaOH. Because of that reason, according to Arrhenius, electrolytic dissociation is a reversible process. The reversible process means it will be represented like this, two arrows. It is a reversible process. That means undissociated NaOH dissociate into ions. Again, these two ions always try to be undissociated NaOH. So this is a reversible process. It depends upon lot of temperatures, pressures and everything. This is all about Arrhenius theory concept. In the Arrhenius concept, one more important thing is, if, fourth point is, if in the electrolytic solution, if the amount of positive charge, the amount of negative charge are equal, then that solution is called as neutral solution. If positive and negative charge, if positive and negative charge are equal, then the solutions are termed as neutral solutions. Remember this, neutral solutions. Now, according to Arrhenius concept, when the electricity is applied, the ions which is formed can be accelerated. అంటే సొల్యూషన్స్ ఇప్పుడు ఏమున్నాయి, అయాన్స్ ఉన్నాయి. అయాన్స్కి ఎలక్ట్రిసిటీ అప్లై చేసినప్పుడు అయాన్స్ అనేవి మూవ్ అవుతూ ఉంటాయి. డ్యూ టు మూవ్మెంట్ ఆఫ్ దీస్ అయాన్స్ ఎలక్ట్రిసిటీ ప్యాసేజ్ విల్ బి పాసిబుల్. అంటే ఈ అయాన్స్ మూవ్ అవ్వడం వల్లనే ఎలక్ట్రిక్ కరెంట్ అనేది పాస్ అవ్వడానికి పాసిబిలిటీ ఉంటుంది. దట్ ఈస్ వై ఫిఫ్త్ పాయింట్ ఈస్ ions get accelerated. Ions get accelerated by applying current. By applying current. This is the fifth point of Arrhenius concept. And next, and one more important thing about Arrhenius concept is, sixth point is, according to Arrhenius concept, the rate of dissociation of ions can be increased as the temperature increases. That means temperature directly proportional to dissociation. Because as temperature increases, kinetic energy increases. For example, this is a solution. It contains positive, minus ions. These are ions. Like this, these are ions. When the temperatures are rising, temperatures are increasing, or when we are heating this solution, the movement of these ions will be increases. Because of that movement, the pass of our current passing is also increases. The rate of current pass is also increases, and the dissociation of ions also increases. So according to Arrhenius, temperature directly proportional to dissociation and temperature directly proportional to current. So this is Arrhenius concept, and according to Arrhenius, he given an equation. That is, in order to calculate the degree of dissociation, అంటే అయాన్స్ అనేవి ఎంత ఫాస్ట్గా డిసోసియేట్ అవుతున్నదో కనుక్కోవడం కోసం ఒక ఈక్వేషన్ ఇచ్చాడు. దట్ ఈక్వేషన్ ఈజ్ కాల్డ్ యాజ్ డిగ్రీ ఆఫ్ డిసోసియేషన్ ఈక్వేషన్. టు క్యాలిక్యులేట్ దట్ డిగ్రీ ఆఫ్ డిసోసియేషన్, సో ఫార్ములా డిగ్రీ ఆఫ్ డిసోసియేషన్ ఈజ్ ఈక్వల్ టు number of atoms, number of atoms dissociated divided by total molecules taken. Total molecules taken. So this is a formula generally used to observe how fast or how much the ions are getting dissociated. So this is called as degree of dissociation, which is popularly called as number of atoms dissociated by total number of molecules taken. By using this formula, we can calculate the degree of dissociation. This is all about Arrhenius theory of electrolytic dissociation. All these postulates. Now, what is meant by electrolysis? What is meant by electrolysis? Electrolysis is very simple process. It is nothing but breakdown of, it is a process of breakdown of electrolyte base. It is the process of breakdown of electrolyte into ions in solutions by passing electric current. So this is called as electrolysis. Electrolysis is nothing but it is a process of breakdown of electrolyte into the ions in solution or in electrolytic solution upon addition of electric current. అంటే ఒక సొల్యూషన్లో ఎలక్ట్రోలైట్స్ పెట్టి ఎలక్ట్రోలైట్స్ని అయాన్స్గా బ్రేక్ చేయడం ఎప్పుడు అది కరెంట్ పాస్ అయినప్పుడు పాసిబుల్ అవుతుంది. సో దట్ ప్రాసెస్ ఈజ్ కాల్డ్ as electrolysis. So I will give a diagrammatic representation for this. So this is the electrolytic chamber. For example, these are the two electrodes. This is electrolytic solution like this. This is the electrolytic solutions. Now for example, this is cathode, this is anode, this is aqueous solution. Now whenever the current is passed through it like this is a plus current charge, this is a negative charge, this is plus charge, this current is passing like this from this to this. Now at cathode generally oxidation occurs, at anode generally reduction occurs. Now when the current is passing through these electrodes, there is a formation or dissociation of these electrodes into positive negative like this. Ions will be generated because of decomposition of these electrodes. So this process of breakdown of electrodes into ions in the presence of aqueous solution or electrolytic solution upon applying of certain amount of electric current is called as electrolysis. Now we are moving on to electrolysis of fused NaCl. Now here we are going to study about how the NaCl is undergoing electrolysis process. First, electrolysis of NaCl are two types. One is electrolysis of NaCl in its fused form, it is also called as silica form, and electrolysis of NaCl in its aqueous form. First we are going to discuss about fused NaCl electrolysis. I will explain with an example now. See, this is electrolysis beaker, electrolysis chamber. This is for fused. So this is fused NaCl. I am taken fused NaCl. These are the two electrodes. This is cathode, positive charge cathode. This is called negative anode. This is anode. This is cathode. Okay, this is cathode. This is NaCl. Now these are the two electrodes which are placed in fused NaCl solution. That means NaCl is in fused form or it is solid form, and now current is passing through it. Now there is a current like this, positive charge, negative charge. There is a current. The current is passing through the solution. Now the NaCl here, the NaCl, due to the application of electric current, this NaCl will be dissociated into two ions like Na plus and Cl. This equation will be like this: 2 moles of NaCl gives rise to 2 moles of Na plus Cl2. So this is the equation generally representing the chemical change that happening within this. This is the 2 moles of NaCl. When it undergoes electrolysis, it gives rise to 2 moles of Na plus. So it moving into opposite charge. Always the movement of ions always happens towards opposite charge. Na is in the case of plus charge, so it moves towards anode. Similarly, Cl2 is a negative charge, so it moves like this, Cl2. So during the electrolysis of fused silica, there are 2 products are produced. One is Cl2 gas, chlorine gas. First product is Cl2 gas, and second product is sodium metal. Sodium metal. Cl2 gas and 2 moles of Na, sodium metal. So these are the 2 products produced at the end of electrolysis of fused NaCl. So this is all about fused NaCl. Now we are going to look after how the electrolysis of aqueous NaCl generally employs. In the case of aqueous NaCl, now there is NaOH here. Now see, this is aqueous NaCl. Similarly, same electrolysis chamber, there is no change in it, but here electrodes are different. These are called as inert electrodes. Inert in the sense these electrodes cannot be reacted, cannot have the property of reacting. So they are called as inert electrodes. Inert. Example for these electrodes are platinum electrodes, PT, platinum electrodes. Now here I already said aqueous. Aqueous in the sense there is a water plus NaCl there. Water and NaCl are there, aqueous NaCl. In the first case, molten, there is no water, but here there is water and NaCl. So these are the inert electrodes. Now there is a current is passing like this, plus charge, minus charge. Current is passing. Now at the end of this electrolysis, there are 3 products are generated. Those are NaCl plus H2O gives rise to 3 products, that is sodium hydroxide, Cl2 plus H2. Cl2 and H2. Cl2 will be formed in this direction, H2 will be goes into direction. These are positive charges, these are negative charges, same as before. These are H2 and NaOH will be formed here in between this. So here see, when the electrolysis of fused NaCl gives 2 products, those are chlorine and sodium metal. But in the electrolysis of aqueous NaCl, it will give rise to 3 different products. One is H2 gas, Cl2 gas and NaOH. The use of first method is to create sodium metal, but the use of this is to generate Cl2. Cl2 gas is very expensive gas. So because of that reason, in order to produce Cl2 gas in massive amount, it is generally used as disinfectant to kill microbes. Cl2 is generally employed. That's why Cl2 gas generation kosam electrolysis of aqueous NaCl, electrolysis of fused NaCl general ga use chestu untaru. So this is all about electrolysis. Applications of electrolysis. Applications are simply nothing but, first it is used for many industrial applications. Especially the technique of electrolysis used in industrial scale. In order to produce or in order to develop certain amount of different kinds of diverse elements, this technique is generally used, and this is mainly used for the development of or production of sodium metal, Na metal, and it is also used for generation of H2 and Cl2 gas. And electrolysis technique is also useful in metallurgical applications. Metallurgical applications. Metallurgical application. It is also used in medicine. It is also used in electrical appliances. See. So coming to the applications of electrolysis, electrolysis is mainly used in industrial purposes, and it is mainly used to synthesize Na plus metal by electrolysis of fused NaCl. It is also used for the generation of H2 and Cl2. It is also used for metallurgical application and for medicine field and electrical application. These are the various applications of electrolysis. Now moving on to second one, that is Faraday's laws of electrolysis. I already explained the definition of electrochemistry. And coming to electrochemistry, each and every branch of science have its own father. For example, science, Aristotle, like that. Similarly, for the electrochemistry also there are father of electrochemistry, but two fathers are there. One is Michael Faraday, second father of electrochemistry is J. Bard. Just a minute, I will explain this topic in a very clearly. Alan J. Bard. So, for example, father of electrochemistry is Michael Faraday. Michael Faraday and Ellen J. Bard. Ellen J. Bard, these two scientists are popularly referred as fathers of electrochemistry. Fathers of electrochemistry. Fathers of electrochemistry. Michael Faraday and Ellen J. Bard are popularly referred as fathers of electrochemistry. So now we are only discussing or concerning about Faraday's laws of electrolysis. Faraday is a scientist who proposed two important laws. Those are called as Faraday's laws of electrolysis. First important law is Faraday's first law. Faraday first law. What is Faraday first law states? Faraday's first law states that the amount of electrode deposited or the amount of deposition of electrode is always directly proportional to amount of electricity passed. For example, this is a chamber, this is the one chamber, these are the electrodes. When electricity is applying like this, A is the electricity is applying to this electrolytic solution. Now at these points especially, decomposition of electrodes takes place. Decomposition of electrodes usually takes place. So according to Faraday's first law of electrolysis, the amount of decomposition of electrodes, how much electrode is decomposed, that amount is always equal to how much we are applying electric current. That means electric current, directly proportional to amount of electrode deposited. So electric current directly proportional to amount of electrode deposited. So Faraday's first law always states that the amount of electrode decomposed is directly proportional to electric current. So electric current directly proportional to, that means Q is equal to IT. This is a formula. This is according to Newton electrolysis law. Q is equal to IT. That means how much electricity we are passing. Similarly, in accordance with electricity, the electrolytic decomposition depends upon. For example, if we apply 10 amperes of electricity, or if we apply 10 amperes of electricity, there is a chance of 10 grams of electro decomposition. If we increase the electric current, there is also chance of increment in the decomposition of electrode. So this is called as Faraday's first law. Faraday's first law of electrolysis. Now Faraday's second law states that, now we are moving on to Faraday's second law of Faraday's second law of electrolysis. Faraday's second law of electrolysis. Faraday's second law of electrolysis mainly states that, just a minute, I want to drink a water. So Faraday's second law of electrolysis mainly states that the amount of chemical changes in the electrolytic solution, electrolytic solution. So Faraday's second law of electrolysis mainly explains about the amount of chemical changes happening within the electrolytic solutions or electrodes of different amounts of current. Here the current capacity is different amounts or different quantities of currents are applied. Amounts of current is directly proportional to their atomic equivalent weights. This is directly proportional to their equivalent weights, atomic equivalence weights. That means the total amount of changes that happening within the electrode when different concentrations of current are applied, those are equal to equivalent weights of atoms present in the electrodes. అంటే ఏంటంటే ఎప్పుడైతే కరెంట్ యొక్క కెపాసిటీ డిఫరెంట్ కాన్సన్ట్రేషన్లో మనం ఎలక్ట్రోలైటిక్ సొల్యూషన్స్కి పంపించినప్పుడు, దట్ మీన్స్ విఆర్ అంటే మనం డిఫరెంట్ ఎలక్ట్రో కరెంట్ యొక్క కాన్సన్ట్రేషన్ పంపిస్తున్నాం. ఒకసారి 10 amperes, ఒకసారి 20 amperes, ఇంకొకసారి 30 amperes. ఇలా పంపించినప్పుడు దాంట్లో కొన్ని చేంజెస్ జరుగుతూ ఉంటుంది. అదే చేంజెస్ ఏంటంటే డికంపోజిషన్. ఆ చేంజెస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ఈక్వివాలెంట్ వెయిట్స్ ఆఫ్ ఆటమ్. అంటే ఆ ఎలక్ట్రోడ్స్లో ఏవైతే ఆటమ్స్ ఉన్నాయో వాటి యొక్క వెయిట్స్కి ఈ చేంజెస్ ఈక్వల్ అయిపోతాయి. సో the amount of changes within the electrolytic solutions when different concentrations of electricity is passed is always directly proportional to equivalent weights of the atoms present within that electrode. So this is all about Faraday's laws of electrolysis. And coming to next is numerical problems. I have already explained these numerical problems, I think, in the colloids and solutions itself, molarity. There also I explained clearly how the electrolysis problems can be asked. Now just a minute, I had a call. Just wait, students. Just a second, I had a call, an important call, and after the completion of this, so these are about Faraday's laws of electrolysis, and so now we have completed electrolysis. So this is all about electrolysis. Now we are moving on to again I want to give a a short and sweet about this electrochemistry. In this technique, in this branch of science, we mainly discussed about conductors. What are conductors? Conducts electricity. Those are two types: metallic conductors, electrolytes. Metallic conductors means there is no decomposition, but electrolytes there is a decomposition into ions. So this is all about metallic conductors and electrolytes. Now moving on to types of electrolytes, two types: strong, weak. Strong means complete dissociation, weak means incomplete dissociation. And third one, Arrhenius theory of electrolytic dissociation. According to Arrhenius, there are many postulates. We have already discussed all those postulates. Now, what is mean by electrolysis? Electrolysis means breakdown of electrodes into ions when electricity is applied. So this is called as electrolysis. Electrolysis are two types: electrolysis of fused NaCl and aqueous NaCl. We already clearly explained what are the products formed at the end of electrolysis of fused NaCl and at the end of aqueous NaCl. So what are the applications of electrolysis? We have studied various applications used for many industrial purposes, used for generation of sodium metal, especially the sodium metal is in the form of reduced form, and H2Cl2 and also sodium hydroxide. We know that sodium hydroxide is very useful in especially in the detergents, especially in detergents. It is also in metallurgical application. Generally, this electrochemistry is always useful, especially in the metallurgical applications, such as different types of techniques such as roasting, calcination, and smelting. And in the medicine sector, how electrolysis is useful is, sometimes these days cancer therapies, cancer treatments are doing. So in that, certain kind of drugs are using which are combining with the metals. So they are called as metallotherapies. So the metals plays a very important role in curing cancers. So in that case also this electrolysis is used, especially in cancer treatment. And electrical appliances means there are plenty of electrical appliances are there in our daily life. Current, fan, fridge, refrigerator, washing machine and micro oven, and these are the electrical appliances there, especially batteries, cars, vehicles, automobile industry is completely based on this electrochemistry studies. So electrolysis is a branch of science which mainly focus and which is mainly confined to many fields of science. So it is very important thing to us. To study electrolysis is very important. And now we are moving on to Faraday's laws of electrolysis. Who is Faraday? Faraday is nothing but is a father of electrochemistry along with Alan J. Bard. So Faraday has proposed two important laws: first law of electrolysis, second law of electrolysis. First law of Faraday electrolysis states that the amount of electrode deposited is always directly proportional to how much amount we are applying electric current. That means electrode decomposition directly proportional to electric current what we are applying. Second one is chemical changes within the electrode when different concentrations of electric current are applied is equivalent to or equal to equivalent weights of atoms in that particular electrode. So this is all about Faraday's second law. In the numerical problems we have already completed in the chapter solutions and colloids. Go through the solutions and colloids, which is taught by me, solutions and colloids. In that, according to the Faraday first law of electrolysis, one problem is also explained, that is that equation is Q is equal to IT. Based on this equation, some problems were solved at that point of time. So you can get an idea about how the numerical problems will be asked in this topic, especially by understanding the concept of solutions and colloids also, because I have already explained the previous year's questions in that chapter. So in order to access this, you can go that and look after that. So this is all about electrochemistry. So these are the numerical problems. I already explained this. What is the electrochemical equivalent of copper when 0 point copper is deposited by the current of 0? So by using the formula I is equal to Q is equal to IT. This is the formula used to calculate this. If you use and if you substitute all the terms into it, you can get an idea about this. Which of the following is the strongest base? Strongest base means the one gives more OH ions, or in certain kind of time strongest base is also called as good electron pair donor also. So based on the calculation of amount of electrons, ఇందులో ఉన్న ఆప్షన్స్లో దేనికైతే ఎలక్ట్రాన్స్ ఎక్కువ ఉంటాయో ఆ ఎక్కువ ఎలక్ట్రాన్స్ ఇచ్చే ఛాన్స్ ఉంటుంది. దెర్ ఇస్ ఎ ప్రాబబిలిటీ ఆఫ్ గివింగ్ maximum number of electrons. So if the one which is with maximum number of electron donating, that is called as strongest base. Which of the following is a weak electrolyte? Simply this is, because this is an acetic acid, it is a weak acid. I already said to you, weak electrolyte means they dissociates into ions incompletely. So the best example for the weak electrolytes is weak acid. So acetic acid is an example for weak acid. So this is the answer. Where HCl is strong acid, NaOH is strong base, H2SO4 also strong acid. So the option 3 is right. A device that converts the energy of combustion of fuels like hydrogen and methane directly into electrical energy is called as electrolytic cell. Simple. Anode used in the electrolytic refining of copper. This is all we have not discussed yet. So in the upcoming sessions we are going to learn about all these things. So this is all about electrolysis. And once again myself Chandra Prakash, Faculty of Chemistry, Ecet. This is Ask Engineering Academy, Dilsukhnagar. It is an institution which has been giving lot of valuable information to the students about various competitive examinations such as Ecet, Mset, IIT and NEET. If the students who are interested to get an admission into this institution, you can get all the necessary details of this institution in the description box given below. So this is all about chemistry. So chemistry is a volatile subject. So try to be attentive in listening chemistry classes. And myself, Chandra Prakash, I graduated from Osmania University in the Department of Chemistry. So if you have any doubts, you can directly message in the link box. I will make you understand what are the doubts, whatever arises in your mindsets. So this is all about today's topic, that is electrolysis. And the next topic I will start about fuels and lubricants after the electrochemical cells. So this is all about today's topic. Thank you so much for listening very patiently my class, and I will be back with one more fascinating topic, that is fuels and lubricants.